In this video, we're going to look at a few reactions of hydrocarbons. Specifically, we'll look at combustion, hydrogenation, and hydration. In a combustion reaction, you have a hydrocarbon reacting with oxygen, and it's going to produce carbon dioxide and water. And so we're going to go through a couple examples of what that looks like writing out the reaction. And so the first example, we're going to look at cyclohexane and write the complete balanced combustion reaction for it. So cyclohexane has 6 carbons and 12 hydrogen. And from what I've just said, it's going to react with oxygen. Remember, oxygen is diatomic, so that's O2. And our products are going to be carbon dioxide and water. Okay, once we have all of our reactants and products written out, then we can start to balance it. You'll notice you have oxygen in as one of the reactants and in both of the products. So we're going to balance oxygen last. So let's start with carbon. We have 6 carbons in our reactant, so I'm going to put a 6 in front of carbon dioxide. That will balance that out. We have 12 hydrogens in cyclohexane, so if I put a 6 in front of water, that will give us 12 hydrogen on the product side. Now that carbon and hydrogen are balanced, let's look at oxygen. So from carbon dioxide, we have 12 oxygen, the 6 times 2, and from water, we have 6 oxygen. So total, we have 18 oxygen on the product side. And so to get 18 oxygen on the reactant side, I can put a 9 here, and that will be balanced. Okay, let's look at one other example. Let's look at ethane. Ethane has a molecular formula of C2H6, and that's going to react with oxygen, O2, and produce carbon dioxide and water. Okay, again, we'll start with carbon. We have 2 carbon in ethane, so I'll put a 2 in front of carbon dioxide. That'll give us 2 carbon there. We have 6 hydrogen in ethane, so I will put a 3 in front of water. That gives us 6 hydrogen on the product side. Now let's count up our oxygen. We have 4 oxygen from carbon dioxide, 3 oxygen from water, so that gives us a total of 7 oxygen, which is a problem since oxygen as a reactant is O2, so we need an even number on the product side. If you get to this point, you can double the coefficients that you've already placed, and that should help work out. So I'm going to put a 2 in front of the ethane because we balanced this so far, assuming there was a 1 there. We haven't decided what our oxygen is going to have. We're going to keep leaving that blank. So now instead of 2 carbon dioxide, we have 4. Instead of 3 waters, we'll have 6. And so that gives us 8 oxygen from carbon dioxide, 6 oxygen from water, and that gives us a total of 14 oxygen. So now we can balance that with a 7 in front of it. So to clean it up, the balanced reaction is 2 of the C2H6 plus 7 O2 gives us 4 carbon dioxide and 6 water. Okay, so for combustion reactions, just remember it's your hydrocarbon reacts with oxygen, which is O2, produces carbon dioxide and water, and then you need to balance it. Let's now look at an addition reaction, and the first one we're going to look at is hydrogenation. And in a hydrogenation reaction, you have an alkene with a double bond reacting with hydrogen, and it will react with the presence of a catalyst. Common catalysts are platinum, nickel, palladium, and you get an alkane from it. Now, if we look at the name of this, we have hydrogen, the word hydrogen in there. So hydrogenation, we are adding hydrogen to our alkene. So let's look at what that does. So it says draw the product when 2-pentene undergoes a hydrogenation reaction. I'm going to start by drawing out 2-pentene. So we have CH3, CH double bond to a CH, so that's 3, CH2, CH3. So there's my 2-pentene. I have a double bond between the second and third carbon. and we're going to react hydrogen to this. So I'm going to draw a hydrogen up here. It's H2, so it's two hydrogens bonding together. The reaction takes place at the functional group, so it takes place at the double bond. The rest of the molecule kind of hangs on for the ride. So when this reaction takes place, you're going to form a new bond between each of the carbons in the double bond and the hydrogens. Your bond between the hydrogens breaks, and one of those double bonds breaks there. And so your product ends up just being the alkane. So you started out with 2-pentene, and we're going to end up with pentane. So now we have CH2 because I've added a hydrogen to that carbon, and a CH2, CH2, CH3. So when an alkene undergoes hydrogenation, you just get the product of that alkane. The last reaction we're going to look at is hydration. This is also an addition reaction, and our reactant is an alkene as well. So you have that double bond in there, and this time we're reacting it with water. Our catalyst is a strong acid that's represented by the H+ above the arrow, and our product is an alcohol. So let's look how that undergoes. So let's see, I will write out, let's see, what is the product when 1-butene undergoes a hydration reaction? So let me write this out. We have CH2. Let's see, my pen is doing weird things. Okay, CH2 double bonded to a CH. Then we have CH2, CH3. And this is a hydration reaction, so we're adding water. I'm going to write that, and the reaction takes place at the double bond again. So I'm going to write that, the water, and I'm going to do HOH here. And what happens in a hydration reaction is that the bond between the oxygen and one of the hydrogen is going to break. One of the double bond breaks. You form a new bond between the oxygen and one of the carbons involved in that bond and the hydrogen and one of the carbons. Now you might be wondering, how do you know which carbon the oxygen is going to bond to and which one just gets the hydrogen? Well, if it's in the middle of your molecule and the carbons are identical, it's going to do to either one. This is at the end of the molecule, and my first carbon number 1 here, this is carbon number 1, has 2 hydrogens. And carbon number 2 only has 1 hydrogen. So the rule is that the carbon with the most hydrogens gets the hydrogen, and the other carbon gets the hydroxyl group, the OH group. So the carbon with the hydrogens get more hydrogens. That's how that works. So this, I'm going to draw it out, is now CH2, and we have, oops, I'm sorry, let me erase that actually. Let's see, erase all that. Let's try this again. So that is now a CH3 because that bonded a hydrogen. We have a single bond to a CH. That carbon now has the hydroxyl group, an OH. That makes it an alcohol. That's the alcohol functional group. And then we just write out the rest of the molecule because it doesn't change. So that is an example of a hydration reaction.